Hey guys, Mrs. Phillips here. Thought I'd do a quick little video of the project I'm going to be posting for you guys to help you hopefully understand it and just give you some pointers as I'm going through. I'm not going to go through the whole thing. You can read it all on your own. First thing I'm going to point out is as of right now, I have a due next Friday. April 17th, okay? That can change. I'm being extremely flexible with everything, but just keep that in mind. I'm shooting for Friday, April 17th. I'm calling this the Ultimate Paper Airplane Challenge. I think some of you really enjoy making paper airplanes, or at least you did when you were in elementary school or maybe 7th grade. Some of you this year have been making lots of paper airplanes in my class. And I just figured that this would be kind of a fun thing to do and possibly even get you outside a little bit just to change things up a bit. I'm going to post this whole assignment as a Google Classroom assignment, so you can just turn everything in on that. It's way easier when you submit all of your assignments in materials actually in that post like you've been doing, as opposed to just emailing me a whole bunch of different things, because email gets jumbled up, so it's easier. I want everybody to create a Google Doc and name it with your first name and last name. That way I know what it is, and all of the pictures and all the work that you do in here is going to be submitted and pasted onto that Google Doc, and then you can just submit one submission for me. It'd be easier. It says you're going to upload your images onto this doc and then submit it to me through Google Classroom. Please do not email me all your projects. It's way easier for me to check your work if it's just submitted through Google Classroom. Okay? So one thing is, I told you in the last renovating the courtyard project, I wanted you guys to print this whole packet and fill it in, and that's pretty much the easiest option. If you can print this packet, fill it in, take pictures of your answers and submit on that Google Doc to me, that would be the easiest. That is not mandatory. If you want, you guys can go through the packet. If you can't print it, just have it up on your screen and you can go through and just type in answers or handwrite your answers. I'm really open, and take pictures of that and send it that way. That way you're not stressing over printing. I have a bunch of you stressed over printing, and I don't want to do that to you. It's not worth it. Never stress over practical math, okay? So just do what you can. If you have questions, let me know. First thing you guys are going to do that I want to point out to you is you're going to find a good paper airplane design. All right, we're going to be taking data about, collecting data about the distance the airplane travels, how straight a path it travels, and how accurate it can hit a target. Okay. So, sorry, I thought something was different there. So, once you find your design, okay, you can go online and look up designs. They have tons of videos on how to fold paper airplanes. You can just, if you have a book of paper airplanes, you can use that. You can just use your own design. It doesn't matter. You're going to practice folding it. If we did it in school, everybody would use the same paper, but basically we're not in school, so you can use what you have. Totally fine. Just use whatever paper you have, but make sure you use the same type of paper for all of your airplanes. And we're just going to fold 3 paper airplanes of that same design. And I want you to just take a picture of the airplanes and upload it onto your Google Docs. So if I had 3 paper airplanes, which I don't, I'd have all 3 of them here. Snap, take a picture, and then put it on my Google Docs so Mrs. Phillips can actually see all the pictures you took, or all the airplanes you made. All right, now we're going to complete tables of data. All right, we're going to use the results from some of these tests to make a scatter plot. And again, I have how you're going to turn in the work, either printing it and taking pictures or doing it by hand. Either way is fine. Okay, here we go. Round 1, hang time round. It says the object of this round is to get your airplane to stay in the air as long as possible. You're going to choose one of your 3 airplanes. Okay, whatever airplane you pick for this round, again, they're all the same airplane design, but I just want you to use this, pick one airplane, use that for this whole round. You need to record in seconds how long your plane stays afloat from the time it leaves your hand until it touches the ground. You can have your cell phone in one hand and press start, throw your airplane up and press stop when it lands on the ground. You can have a friend or a brother or sister or mom, dad, somebody do the timing for you. It doesn't matter. There are different methods that you can do to keep it in the air the longest. So whatever method you choose, use that the entire time, right? And then go ahead, describe your method that you're going to use here, and then go ahead and do it 10 times, throwing your airplane in the air and timing it for how long it's in the air in seconds along this column. Okay, so that's the first one, and I'll try to send videos of how I'm doing this so you can have some better examples. Second one's velocity round. It says get your airplane to travel the furthest distance and determine if there's a correlation between distance and time. So, and for this round, you're going to pick a different airplane from your stash of 3 airplanes. So you already used one in the previous round. You're going to pick a new one for this round. And basically you're going to create, and you can use tape if you want, or just a stick or a piece of paper, something to mark a starting line. And you're going to stand at that starting line and just launch your paper airplane forward, right? And it says, after you launch your paper airplane, you're going to record in seconds how long your plane stayed afloat from the time it left your hand until it touches the ground, and that's the horizontal launch. All right, so you're going to do that. Then you're going to measure the distance in inches or feet it traveled from the starting line. Okay, so you have 10 different trials. You're going to do this 10 times, how long it was in the air, and the distance it is from your starting line to that particular airplane spot where it landed. All right, so it's going to be like this. You'll have your starting point, whatever it is. You are going to, here's you, you're standing here. You're going to launch that paper airplane. It's going to land somewhere. Let's say it lands right here. And you're going to take the time in seconds. And then you're also going to measure the distance from the starting point to the plane. And you can measure that in feet or inches or whatever. Hopefully it goes more than inches. Hopefully it goes a lot of feet. Okay, and that's what you're going to record in your table. And you'll notice that I have an X here and a Y here, and then the coordinates X, Y. So basically this is going to represent your X values, this is going to represent your Y values, and then you'll have your X, Y coordinates. And I talk about that later. You don't need to fill this one in yet. Okay. The next part is stay on the straight path, and basically what you're going to be doing is a similar thing to the last one. You're going to have your starting point and you're going to launch it, but you need something extra in this one. You basically want to find a straight path, such as a fence, the side of your house. You can use tape to create a straight path. That's what I did in the hall last year and outside. You could use, if you have hardwood floor, you could use one of the planks of your hardwood floor. And you're going to create a starting point and then launch your plane from that starting point and try to get it to follow right along the straight path you chose. You'll be measuring the vertical distance the plane traveled and the distance the plane moved horizontally from the straight path. So I have a little drawing here. What's going to happen is here's your starting point. Here's your straight path. Maybe you're going to use the side of your house as your straight path. Again, it could be a plank of wood. It could be a piece of tape that you draw. And you're going to launch your airplane. All right, there it goes, and it veers to the side. And what you're going to measure is you're going to measure the distance from the starting point the whole way to the tip of the plane, just like you did on the previous experiment. And you're also going to measure the distance the plane traveled horizontally, all right, from your straight path over to the airplane. So you'll have this distance and this distance, and that is what you're going to write in your table. You have your horizontal distance, which is this, and then you also have your vertical distance in the second column, or the third column, which is this. Fill that in, and notice again I have an X and a Y in your coordinates. You don't need to worry about that yet. Okay, I'm going to pause here and come back with a different video to explain the graphs.